start recording. Yeah, you're the best. I did want to let everyone know that we are recording tonight's webinar, and it will be made available on our website. I'll let you know where you'll be able to find it and view it later. And we're just thrilled that you're joining us tonight. So welcome to tonight's Global Precipitation Measurement, or GPM, Mission's third of our 10 and 10 10-year anniversary webinar series. That's a lot to put into one sentence. Tonight, we're focusing on NASA's amazing contributions to helping us better understand and protect our home planet as we draw closer to Earth Day. And we truly have an incredible lineup for you. Although I imagine when you registered, you've already read over the bio sketches for tonight's speakers, I will give a shortened version for each speaker now as I introduce them to you before we get started. We're going to begin by learning about NASA's overall Earth science efforts from none other than the former GPM Mission Deputy Project Scientist for Applications, Dr. Dalia Kirschbaum. And Dalia Kirschbaum is now the Director of Earth Sciences Division at NASA's Goddard Space Flight Center in Greenbelt, Maryland. As the director, she manages a staff of 200 civil servants and 1,200 people who are serving as contractors, technicians, support staff, and those on cooperative agreements, all dedicated to studying Earth as an integrated system that includes the atmosphere, oceans, biosphere, cryosphere, and geosphere. After Dalia's presentation, we're going to pivot to learning about one of NASA's flagship outreach programs called the GLOBE, or Global Learning and Observations to Benefit the Environment program, from Dr. Amy Chen. She serves as NASA's program coordinator for the GLOBE program. In this role, she provides coordination and strategic leadership for the program. She oversees the GLOBE Implementation Office and the GLOBE Data Information System, and builds connectivity from the Earth Science Division missions and research, and works with GLOBE federal co-sponsors, who include NOAA, the National Science Foundation, and the United States Department of State. After Amy's presentation, we will hear about some of the special partnerships and programs that have been formed between NASA and many other outside organizations to increase awareness and stewardship in Earth sciences from Matt Pearce. Matt is the Education Program Specialist with NASA's Goddard Space Flight Center Office of STEM Engagement, which is located in downtown New York City at the NASA Goddard Institute for Space Studies. And then we're going to pivot to engaging with Liz Saccoccia, and she works for an amazing nonprofit organization called the World Resources Institute. I had the opportunity to work with her when we were developing application packages. And when I heard about the work that she does, and you will get the opportunity to hear this as well, I thought, oh my goodness, if I were starting in a career again, World Resources Institute is definitely one of the places that would be at the top of my list. An absolutely amazing place, and you'll learn more about that. Liz is a water security associate on the World Resources Institute's water team. She works with governments, companies, and research partners to advance best practices in water resources management and to enable sustainable growth in a water-constrained world. And the reason that we are including Liz, and we will be continuing to include other people from outside NASA throughout our webinars, is because she and her company, her nonprofit organization, utilize GPM and NASA data in their work. And then finally, I will take up the rear. I serve as the GPM Outreach Coordinator and have enjoyed being a part of this hugely successful mission since 2011. I will be sharing our resource packet, which will be made available to all of you. I'll put the link for it in the chat, and I'll also be putting it on the website that you went to register. So you'll be able to find that as well as tonight's recording. This resource packet We'll have information on all the programs and websites that are mentioned in tonight's program, plus more. So sit back and prepare to be dazzled by these shining stars who will not only tell you about their work, their colleagues' work, but will also invite you to find a part that you can play in our efforts to make this planet a more sustainable place for all of us. So now, without further ado, I will offer the floor up to Dalia Kirschbaum.
Well, thank you so much, Dorian. You know, sometimes I think the beginning, preambles have now been taken over by AI, but I know that every word that Dorian wrote is from the heart and her own. So I'll just say that. Thank you so much. It is such a pleasure to be with you and to take time to talk with you a bit about what we are excited to share here at NASA Goddard. Let me just share my screen really quickly.
Very good. And I will give you the A-OK that you're showing just fine before I disappear.
Perfect. All right. Give a second.
Indeed.
It worked before, which means that it's never going to work the second time. Where did it go? Okay, here we go. Slideshow from beginning. And display switch. How are we doing?
I'll let you know. It's just, you're golden. You're beautiful.
All right. Well, again, it's such a pleasure to speak with you. As Dorian said, I've been in this role as Earth Science Director at NASA Goddard for a little less than 2 years. And I'm excited to talk with you about really exploring our home planet and what NASA is really focused on to do that. So first, I want to start with kind of the big picture, which is the goal of where we are in Earth science. We just saw an eclipse, which was amazing. And it just reminds us of the unique position that we are here on Earth. And so at NASA, we have a tremendous capability to study the Earth from space. And we do that by innovating, by integrating, and by informing for impact. And that's really where I'm going to talk to you about today. I want to make sure I'm on the right side of time, so I'll keep that. So before we jump into the science, I wanted to start with a personal note. So I started my career working with Chen, the Tropical Rainfall Measuring Mission, and then moved on to work with the Global Precipitation Measurement Mission, which is the series that we're in here. And GPM has been a tremendous workhorse satellite to better understand where and when it's raining all over the world. But the reason I say it's personal is because I got to be there when it was built. And that is what's so exciting about NASA. So this is me in my bunny suit, in front of a fully assembled GPM spacecraft before it launched from Tanegashima Space Center in Japan. And just being close to this satellite that was about the size of a small school bus and realizing the importance that is going to play at the national and international scale was so humbling. And it reminds me, while NASA studies the moon, it studies the cosmos with the James Webb Space Telescope, we also have such important missions to study our home planet. And we do that with a series of satellites, about over 24, taking the pulse of our home planet. Some go around more towards the equator, some go over the poles, some sit in a geostationary orbit way far out to look at one place of the Earth at a time. But a really important piece here is to make sure we don't just look at one component at a time. We look at Earth as a system, right? So we understand how water vapor that we can model with models and observe with different types of satellite retrievals can be helps to understand the distribution of water around our planet, from precipitation to soil moisture, and where that will factor into the health of our rivers, our estuaries, and our oceans. Now, at NASA, we have a tremendous amount of data. So what you see here, we call the data download. And this is an example of a time slice of 6 hours of data that we use to better understand the Earth. Now you can see there's airborne satellites, airborne assets. You can see those yellow, even on aircraft we partner with commercial airlines. We have different satellites in orbit. And so by bringing all of this data together, 6 million data points in 6 hours and growing exponentially, it helps us to get this much bigger, richer picture of how things are changing on our home planet. So let's start with our Earth's refrigerator. We'll start with the Arctic, right? So the Arctic is a really important place for a number of reasons. One is that it provides this reflectivity, this energy reflection to space to help us reflect some of the energy that may already would have been trapped by warm ocean water, right? So that helps us to cool our planet. And so by being able to track the health and the size of the ice sheets and the thickness of our ice sheets with missions such as ISAT-2 and optical images, we can see how this critical area is changing over time. And so what you see in the graph is that the area of extent of sea ice has gradually been getting smaller and smaller. Now, of course, it's not perfectly linear down, but it is changing in a very clear direction. Similarly, we can take other observations with satellites that look at the underground storage, that they look at gravity in our Earth. And so when you take these two satellites and they fly over a place, they measure the distance between them. They're calibrated to within a human hair, these two spacecraft. And with GRACE and the GRACE follow-on mission, they can look at ice changes. They can also look at extremes in whether it's really, really wet or really, really dry under the surface. And so what you're seeing is ice mass changes in Greenland over time. And by being able to combine information and then check it with ground-based systems, so we send teams up collaboratively with our other federal partners to really measure ice volume and ice movement. But you can start to see how we piece together this picture of how sea level may be affected by changes in the Greenland ice sheets. So if we look at that kind of a bit more broadly, we can look at how ice is interacting with our biosphere, right? On land, looking at vegetation green up, as well as our oceans. So we actually call this the Earth breathing, because this is how it kind of looks, right? Our oceans have dead zones, those are in purple, where there's not a lot of activity relative to some of the chlorophyll and other contents. And so this is the picture. You can look at the time. This is pretty old, kind of bringing together information on land and oceans from 2000 and up. And so we've had really important measurements of our oceans to really look at these changes in areas of chlorophyll and how that productivity comes off our rivers, et cetera. But the really exciting thing is that not that long ago, we launched the Pearce satellite that's designed to look at chlorophyll, look at ocean health, and also look at aerosols and clouds in the air. And today, this is very well timed, we came out with the first public images of our oceans. Now, it may not look like the James Webb Space Telescope images in the formation of the galaxies, but this is as close as you get to revolutionary images of our oceans. And we just are launching them today. So what you see here, this is from the Pearce satellite, and it's called the Ocean Color Instrument. This is from the tip of South Africa. And so in the left, you see the true color image, right? We have a capability called hyperspectral satellite capabilities. And so from that, you can see these true color images. The ocean has lots of different colors based on the things, mostly the different tiny plants that live there. But when you use different types of the electromagnetic spectrum, you're able to see different types of things that grow in our ocean, of the different types of communities of phytoplankton. So I'm not even going to attempt to pronounce these because that is not my area of expertise, except for chlorophyll A. But what you can see is how much we are going to learn about the health of our oceans. And that affects our coastal regions, our estuaries, our fisheries, tourism and transportation, the like. So we are so excited. And today was the day. Well, I don't have a favorite mission, but I kind of do. And that's the Global Precipitation Measurement Mission. And one of the reasons is because I've been spending most of my career focused on how we understand where and when rainfall happens and how that impacts things like natural hazards. So as we were talking in the introductions, I pulled this. So this is the last 7 days of precipitation as observed by GPM. And what you can see is the distribution around the world of heavy precipitation, snow in blue and purples. And I could spend the rest of the time talking about this, but I have so many other cool graphics and things to talk to you about that I'm going to keep going. And one of the things is how we use the GPM satellite, which has both active and passive observations, to look at things like storms. So this is a flyover of a huge system And what GPM can do is look layer by layer through the storm and understand where it may intensify, right? This is the first time we've had a view of snow at the top of hurricanes. And looking at these hot towers, you see in the center of the storm, it goes over 10 kilometers in height. This is where you have these strong convective towers that indicate the storm may intensify. So this type of information is critical for weather forecasters, hurricane modelers to put together as part of a bigger suite of information to create better forecasts for our communities around the world. And the other way that we can use this information is looking at extremes. So GPM can look at what the precipitation, the rain and snow looks like. But with the satellites I introduced before called GISS, you can also see how these big extremes are changing underground. And so what you see here is the extremes, both droughts in red and floods in blue. And on the bottom, you see the global temperature change and the total intensity of those major events. And so what we see with this diagram is that we can see with our long records that the extremes are getting more extreme. And by looking at changes in rainfall, changes in underground water because of extreme drought or extreme floods, it helps us to provide that objective, open picture of where we are and where we might go. At the same time, and it's great to see the World Resources Institute on, this data is important to look at in a broader context of people and impacts. So this is something I find really interesting. What you see in this South Africa graphic is the changes in rainfall from normal. So brown is below normal, blue is above normal. And we have scientists that are working collaboratively across our federal family and in academia to correlate that with things like Rift Valley fever. And so that's where you see these dots popping up and how they are occurring with areas of El Nino and La Nina in addition to rainfall. And so by looking at the confluence of rainfall, of vegetation conditions, mosquito habitats, we can get a sense of where we may have vector-borne diseases, or even after major events like a hurricane, where we may have outbreaks of cholera, and that's a waterborne disease. And so we have scientists that are working on combining this information. We also have this, let me start again. We also have really important observations, long-running observations of our planet through the Landsat series. And Landsat is the longest-running Earth observation platform in the world, and we continue to make key observations of how the human environment is being impacted and is impacting these areas. Now, does anyone have a guess of where this is? Las Vegas. Okay, so I know that a lot of people start to see, the strip, and they see these red areas, which are vegetation. I'm looking at Lake Mead, right? I'm looking at how much Lake Mead is shrinking over time as a result of people and the communities there pulling water to create this sprawling community. And so that dynamic is really important, and that's why space is really one of the only vehicles to look at this in a big picture over the globe. But we need to complement that with ground-based observations from citizen scientists, so we get an understanding of how this all connects. Another really powerful way that we look at how we use satellites to understand human impacts is by looking at how our cities behave. So what you just saw was the Hurricane Maria, which devastated the island of Puerto Rico. And so what we're going to do is we're actually going to zoom in on the island to get a sense of how it was affected in terms of the night lights, right? So from satellites, we can actually see the light pollution. So this is, you see San Juan, and this is the baseline. This is what Puerto Rico looked like before Hurricane Maria. And now what you're seeing is the path of Hurricane Maria, the eye, and what it looked like after. And now you're seeing how the power was restored to the island and how long it took, right? And so by being able to have an understanding of where people may need to have generators installed, right? Where we work with with a ton of different response organizations, the Coast Guard, FEMA, and others to provide information so they understand where these communities may be affected by resulting power outages. And also, just to make another mention, this also caused a lot of landslides this storm. And so by being able to take optical and commercial imagery, we're able to get a sense of where there may be roads blocked. So this is the power that satellites have and why NASA studies this. And we can't do it alone. We need to do it with our federal family, with our academic partners, and with people all over the world. We partner with space agencies all over the world to make these missions a reality. So what it comes down to is bringing observations into ways to understand the Earth as a system. And we do that with models, right? We understand how this is an example of aerosols, so the different types of dust and sulfates and sea salt, how they're connected. And so we bring in satellite observation to inform model physics and to kind of what we call start them, to move them, parameterize them to go forward. So we also take observations, and so I know Matt Pearce is up from GISS. We have a collaboration with NOAA to look at climate change over time. And so these are temperature records in 5-year increments, really looking towards how our climate is changing via temperature. Now, as you see, this is not equally distributed. Some areas are going to experience and already are experiencing more warming than other areas. And so our goal here is to observe these changes, provide models of the past to see if we can get it right, and then look to observe the present and develop models for seasonal forecasting, et cetera, and then project out into the future. And that's where this comes in. So this work takes the climate modeling work that GISS does and combines it with crop models to understand how things like maize or corn yields may change into the future. Now, this is not in the past. Look, these are projections into the future. And so by being able to look at lots of different crops and where there may be either poor or better growing areas for these crops, it helps communities and planning become more resilient to these changes. And so this is work that the Climate Impacts Group at GISS has been working on, and it really takes quite a lot of different types of data to better understand these future projections. And so I want to just close with an understanding of where we're going, right? So I showed you this tremendous amount of satellite data that we already have, but we're moving towards the Earth System Observatory, where we're going to realize connections between clouds, convection, precipitation, aerosols, how things are changing underground, how our land surface is changing. And so just to close, what can you do? I hope that this excites you, because I absolutely love going to work every day. What can we do? Well, first of all, you can be informed. Climate.nasa.gov, GPM.nasa.gov. There are so many resources that Dorian is going to fill you in on to really understand where we're at and how to be an informed citizen about where we need to go or where we're going. We'll hear about citizen science with Globe, and that's such a critical piece of getting involved. Everything from kindergarten all the way to our more senior community members. It's critical to provide this information. I developed our own citizen science app for landslides to really get a sense of how we can bring more community input. And finally, to be inspired. I hope the eclipse inspired you. I hope James Webb inspires you. And I hope that the Pace first light images from today also inspire you to understand how NASA is helping our home planet. So with that, would love to take questions, and I'll turn it back to Dorian. Thank you.
Dr. Kirschbaum, thank you so much. I'm sure everyone just seen all of this different data and the various ways in which, these data are being collected, and some of the ways in which they can be interpreted and then used by others. I'm sure it is as inspiring to others as it is. I hear about these many, many times, and each time I hear about them, I swear I get goosebumps, because it's just incredible that using satellites and remote sensing, and also having ground observations as well, that we're able to do so much and gain such an in-depth understanding with all different parts of Earth systems. So thank you very much. And if people have questions for Dr. Kirschbaum, if you'll put them in the chat, and that way we will go ahead and we will move on to Dr. Amy Chen, who's going to tell us how we take all of these amazing data sets and this information and these phenomenal scientists, and how over the past 30 years, I think it is, since 1974, there is a program that has been developed to at least offer some interconnectivity between what we're seeing at NASA and then what we are able to collect from the ground in a systematic way. So without further ado, and unfortunately, Dr. Chen's camera is not working. So we will be able to hear her voice, and that's what really matters. Dr. Chen, right now you're in presenter mode, and I'll let you know when you are in the perfect mode.
Okay, presenter mode. How is that?
You're perfect. Thank you so much.
Okay. Well, great. And thank you, Dorian. And my apologies. I just tried again, but I don't think my video is working tonight. So I may as well just turn it off. Okay. So that was great from Dalia. Thank you. And now I want to tell you a little bit about another NASA program, and this is the GLOW program, the Global Learning and Observations to Benefit the Environment program. We're marching into our 30th anniversary in calendar year 2025. Actually, the Earth Day is GLOW's birthday every year. So if you like, you should join us on Earth Day and go to globe.gov and you can celebrate with us. Okay, let's see if I can go to the next screen. There it is. So GLOW was launched in 1995 as an international science and inquiry-based education program. So we really have those two dual goals, to advance science and to advance inquiry-based education and training. So GLOW is currently in operation in 127 countries, and 127 countries around the world has signed a bilateral agreement with the US government to indicate their commitment and willingness to implement GLOW in their country. So we have, over the years, over the program's tenure, we have accumulated almost 50,000 educators worldwide. And we have nearly that many for schools and informal organizations. We have students, citizen scientists, as well as scientists and educators. And we have amassed, I'm sure by now it's probably over 250 million measurements that the participant have collected collectively. So the program engages participants through hands-on scientific activities, and our goals are to improve science education, improve environmental awareness, and to improve understanding of the Earth as a system. GLOW has received quite a few awards over the years. Most recently, we received the 2021 AGU Award for Excellence in Earth and Space Science Education. So GLOW is organized into 4 main spheres. So these are called the GLOW protocols, and they are the backbone of the GLOW program, as we call them. The protocols were originally developed by research scientists and with the GLOW's education focus in mind. So each protocol outlines a data collection methodology as well as specifications for affordable instruments that meet measurement requirements. These protocols span the atmosphere, biosphere, hydrosphere, and pedosphere, and many of them are bundled together to address a particular aspect of the dynamic and interconnected Earth system, which I think you're getting a sense that is a theme here of what we do in NASA Earth Science. So GLOW has many freely available educational materials, and they have been translated into multiple languages. They have been aligned with the next generation science standards, and have been, most importantly, they have been tested many times in both formal and informal educational settings. So, what do GLOW participants do? So in a nutshell, the GLOW participants, they collect data and they conduct analysis. They upload the data into the GLOW database, and they download and analyze the data, and they submit and present their findings. And most importantly, they have a lot of fun together. There's a lot of cultural exchanges, as you can imagine. Every time we have either a regional meeting or we have an annual meeting, which is coming up for GLOBE in middle of July. So again, the fundamental emphasis for GLOBE is to engage students in hands-on learning of Earth system science and to help them develop scientific habits of mind through inquiry-based learning. So, they collect these measurements following the GLOBE protocols, and they contribute, in the process, they contribute to better understanding of the Earth system as a whole. Okay, and so here I want to give you examples of an annual event that we have with the GLOBE community, and that is the International Virtual Student Symposium. So in this year, we broke the record. We have almost 280 student projects from 30 countries. So the International Virtual Science Symposium is an opportunity for GLOBE participants to showcase their projects using GLOBE protocols. And these projects runs the gamut, as you can see on the screen. Some of them would explore mosquito larvae habitat. Some of them are about collecting biophysical chemical characteristics. Some of them are about, looking at variations of fish in, irrigation systems and climatological projects and how they influence the Earth system. So they really is, we leave it to the students' imagination. How can they use the GLOBE protocols, about 40 of them, to investigate a particular aspect of their local environment of their interests? And so when students who submit projects, they're eligible to be entered into a lottery, and the lottery is drawn on Earth Day during our Earth Day celebration for GLOBE. And for a project that scores well, they get entered into lottery, and they can have a trip to the GLOBE annual meeting, and that's very exciting for our participants. So what I have, maybe Dorian will share the link if you want to learn more about some of these projects that I have here on the screen in more detail. So in the US, we also run a student research symposium every year. And back in 2023, we have 4 regional symposia that took place between April and May. And in 2023, we engaged 218 students. They presented 86 projects altogether. There were 45 educators that attended as well, and they were supported by 10 US GLOBE partnerships. We had reviewers, scientists, and event support staff. And this is I want to say this is a very collaborative and learning environment for all the participants. So one of the #1 emphasis for either the IVSS, this International Virtual Science Symposium that I just mentioned, or the SRS within the US, is that we focus on giving students the feedback to help them grow. And we have, from the evaluation results, which I show on the bottom here, you can see that the students, through putting together their projects and participating in SRS, they really gain these 21st century skills, and they learn the scientific practice of any scientist would do in the professional setting. So they learn to work together as a group. They learn to present their research results. Through the process, they learn to ask questions and make observations and record data, and figure out what the data actually tell them and whether or not they can, it supports their hypothesis, and if not, why not? And through the event, when students participate in the event, they also identify themselves as a scientist. They think that they're able to present their research project better. They're able to construct scientific arguments, and they really identify scientists as like them. So that's it's a great, and it's a great way for them to really learn about the scientific process, and they form a community with their fellow participants, with the other educators and scientists that attend and give them feedback. And on this slide, I want to show you some precipitation-related GLOBE projects and stories over the years. In 2015, GLOBE in Nigeria held a GPM event. And in 2021, students in Mississippi collected GLOBE atmosphere and precipitation data to see how barometric pressure affected storm intensity. And in 2020, there was in Taiwan, GLOBE students look at the relationship between rainfall and soil pH. And I just want to emphasize again that these are student-led projects. And again, student has a complete freedom to choose what they want to investigate. And a lot of time they have local relevance. And the other thing that research has shown is also that inquiry-based learning is very efficacious for retaining knowledge and applying them toward real-world problems. Okay, so the GLOBE data that the participant collects, if they so choose, they enter into the GLOBE database, which NASA supports. And these data that's in the database are freely available to anyone. And over the years, we have scientists that partner with GLOBE students, or they just take they examine what data are available in our database to answer particular research questions. And I show 3 examples here of this kind of collaboration that GLOBE has had over the years. So you really can think of GLOBE as one of the oldest form of citizen science and science and scientists and student collaborations. So you can look at on the left hand, the first column on the left here, where the student data were integrated into the climate monitoring activity and CDC, where the data from 57 schools from 14 countries were evaluated on whether or not they meet the QC standards, and they did. And in the middle here, where you have a soil vegetation dynamic model, where you have to provide the input for that includes weather, soil, and phenological data. And most of these data were largely collected by GLOBE participants to inform this kind of study. And on the right-hand side here, in 2008, there were 100 schools in Croatia where they collected water samples and measured air temperatures so that a sample could be analyzed by stable isotopes in the university to better understand the complex weather conditions throughout the country. And here is a slide where I just want to show you a snapshot of GLOBE in action in 2023. So the 127 countries that participate in GLOBE are organized into 6 different regions. And they are active and doing all sorts of interesting activities every year. On the top left here, we have biodiversity champions, where the South African students joined the Bioscape campaign, which is a NASA airborne science campaign. They held a teacher training workshop with 170 students from 8 schools, and they were training on GLOBE protocols while the Bioscape team was visiting and taking biodiversity measurements. On the bottom here, there are 48 attendees at a regional meeting in Latin America and Caribbean region, which is coincidental to the annual polar eclipse event back in October in Panama City. And in the middle here, we have an actively running phenology campaign in North America, and is a collaboration between the student in the county Cork, Ireland, and the New Hampshire, shown in the middle here. And on the bottom here, we have elementary school in Kuwait, teaching grades 3 to 5 about the GLOBE program and the cloud protocols. On the top right there, we have the GLOBE Asia region office, and Maldives facilitated 151 participants from 7 countries to engage in hands-on learning about the effect of climate change in the city. I'm not going to be able to pronounce it correctly, but Humi Maoli. And then on the bottom here, this Globe Italia organized World Water Day was river and spring event that drew 1,000+ participants who visited 49 sites along a lake. So, in different Globe regions, they organize different events, and they are. I see that there are international people listening in to this webinar, which is great. And you can easily search on globe.gov to see, if you're in a Globe country, some of these activities. Okay, and the last thing I will mention on my slide is that collaborations with the Airborne Science Program and science team there. And also in 2023, as I mentioned, the Bioscape campaign was down in South Africa, and the South Africa is a very active Globe country as well. And they were learning about the Globe protocols that are related to the campaign and taking measurements and doing protocol training together. So I hope that gives you a sense of the Globe program, and I am happy to answer any questions. And thank you, Dorian, for the opportunity.
Thank you very much. We really appreciate it. It is really neat to see how you can take these, this huge array of data that we have through the NASA Earth Science program and really work on deliberatively networking with schools, with scientists, and I'm really happy to say also with citizen scientists. When you take a look, and thank you for letting me know, I don't know how on earth the wrong URL got in there, but the right URL we have now, and that URL will tell you not only about the Globe program, and we'll have all those different links that were being shared by Larissa. Thank you so much, Larissa. But it will also, and Matt, you can go ahead and put your slides up. It will also enable you to be able to look at the Globe Observer program. And that is a program that you simply use your smartphone, and there are 4 tools on there. And then you can you'll be able to collect data that then you will be able to compare and contrast with some of the NASA satellite data, as well as be able to compare it and take a look at the data that's being collected all around the world. I believe that we need to get Dr. Chen to stop sharing, and then we will be able to get Matt to be able to start sharing. So we'll wait a sec for Dr. Chen to stop sharing. And we all know, oh, thank you, perfect. All know who, after going through COVID and going through the years of things online, how things don't always work quite as seamlessly as we would like them to. So we're gonna now hear from Matt. I do not yet have the various programs up that he's going to talk about onto the resource packet because I hadn't gotten them, but he has sent them now, and by tomorrow afternoon, I will add them. So even if you take a look today at the resource packet, take a look at it tomorrow and the next day, because it will continue to grow. All right, without further ado, drum roll, please. And you are on, Matt.
All right, thank you, Dorian, and hi, everyone. It's a real pleasure and privilege to be here with my esteemed colleagues and friends tonight. You're lucky to have the champions of Earth science and Goddard and NASA and science, and it's a real honor to be here. Hi, everyone. My name is Matt Pearce. I'm coming to you live from the Goddard Institute for Space Studies in New York City, and my hope is to share with you some of the different projects and programs I work on and help you to kind of understand a little bit more about my role and how potentially you can connect with other NASA, Earth science, and STEM related opportunities. The broad brush of my role is to improve STEM and climate change education, utilizing NASA as a vehicle to do that. for all formal and informal education groups with an emphasis on supporting underserved and underrepresented communities. And I have the privilege of working with scientists at GISS, at Goddard, and all across the agency, and also work at headquarters with NASA's Office of STEM Engagement. I'm at the intersection of science and STEM in many of our education efforts. I want to share with you a little bit about GISS, a program called the Climate Change Research Initiative, some of our educator ambassador programs. I want to invite you to a virtual platform for educators called NASA Connects, and also want to share with you some additional resources that you might be interested in engaging with. And our hope is to connect you not just with our missions, but get you to contribute to them in meaningful ways that are of interest. So GISS is a fascinating place. It is, and you heard Dalia mention earlier, a lot of information about climate modeling comes out of GISS. It's a really fascinating place to work. The team here looks at remote sensing data of aerosols and clouds and the planet. Our climate impacts and climate modeling team take a lot of that data and do just fascinating, complex work to do predictive analytics and representations of what's happening to our planet. But it's also a very fascinating place because many of our scientists take the lessons learned from our Earth observations and look out into the solar system and the universe to look at what potential future habitable planets may look like, or what an early type Earth may have been. So it's a really, really dynamic, unique intersection of science. We're deeply integrated with Columbia University, the Earth Sciences Division, Goddard Space Flight Center, Lamont Doherty Earth Observatory, and many of the other education and science institutions in the region and also across the world. And I lead a neat program called NASA's Climate Change Research Initiative by the Office of STEM Engagement for Science Mission Directorate. And the NASA Office of STEM Engagement's vision is to immerse the public in NASA's work, enhance STEM literacy, and inspire the next generation to explore. We are trying to engage the nation in NASA's mission. And you can see in some of the bullet points, we really do create opportunities for the public to contribute to NASA's work. That GLOBE program that Dr. Chen just highlighted is an amazing example of citizen science and educators and communities from around the world coming together to do science. I wish I would have known about it when I was in the classroom as a teacher. But we definitely want to build authentic learning experiences and develop powerful connection to NASA's mission and work. So a quick highlight, trying to give you a quick snapshot of GISS and what we do here. I lead a portfolio of engagement from K-12 higher education programs. We integrate with nonprofit and informal educations. We often come together as community members with nonprofits and the museums to provide STEM engagement events. We also provide an innumerate number of educator professional development opportunities. I work very closely with teachers to improve their STEM capacity in their classrooms. And by virtue of all these engagements and the powerful teachers that are out there, we have a Climate Change Research Initiative Educator Ambassador Program. And if we have any teachers on the call that are interested in these types of things, I value, please reach out to me if you'd like to join or consider looking into some of these programs. And I also work very closely with institutions to develop partnerships, relationships, collaborations, both with external institutions and other federal agencies to build dynamic education opportunities. The graph on the right is a model of a program that I lead called the Climate Change Research Initiative. And I think I have it here to kind of share not just the program, but the interdisciplinary nature of this type of science that's done here at GISS, across the agency and across STEM disciplines. In short, I build research teams that are a near-peer vertical team mentoring model. I create teams that consist of a NASA scientist, a teacher, a grad student, an undergrad, and a high school intern. and they work together for a year on very complex questions related to climate science. And then we work very closely with those teachers to develop integrative unit plans, create community STEM engagement events, and really try to partner with those teachers in those communities to meet their students where they are. And again, if that program interests you, we are beginning a second cycle of applications for next year. And again, please reach out to me. If you're interested in the topics of that program, in the bottom left, you can see the various titles of the projects. And we have projects that utilize NASA satellite data, ground truthing data, but we're looking at extreme climate events. We're looking at the Hudson estuary marshes to identify how substantial of carbon sinks they are. We have teams that are analyzing the urban heat island effect and coming up with unique strategies, not just for mitigation, but how to improve the measure in which we study that science. We have teams that are studying lakes from space and looking at harmful algal blooms. And that PACE mission that you saw earlier will be a critical tool in that study. Being able to measure the different types of phytoplankton and everything else that goes on in those environments is key to our understanding. It's a really exciting day to have this talk on the day that PACE data just became, got our first images. And on a previous slide, you saw the SNOWX campaign. One of our teams is doing deep analysis on what is happening with snow water equivalencies across different snow areas. Great programs. I've got some other metrics on there that give a sense of how our small but mighty team are out really engaging schools and communities. Many of our teachers will utilize GLOBE in their efforts and their unit plans that they develop. It is a powerful program that has a lot of scalability, versatility, and enables students to increase their capacity and research and capacity in STEM. And one of the things I love about that GLOBE program is how well it connects communities. Science is an international sport, and it is a great collaborative tool as well. Some of our highlights, many of our teachers have had their unit plans published by Science Mission Directorate due to their excellence and commitment to that. We have teachers that are publishing in peer-reviewed science journals, such as the National Academies. And it's a really neat way. I firmly believe that teachers and citizen scientists are essential members of the NASA mission. I talked briefly about the Educator Ambassador Program. If you're an in-service teacher and you want to consider applying for this, please reach out. My contact information will be in the supplemental resources. But I also wanted to highlight another project that I lead. Down in the bottom right of this slide, you're seeing a International Space Station downlink event. And one of our climate change research initiative teachers was able to take her science and apply for a downlink event. And we're able to get a talk from Space Station down to their school and community. And it was all about Earth science. So it was a really neat way to connect students, not just with their futures, but also with the space station. For educators, whether you're formal or informal educators, I want you to get out your phones and point it at that QR code. This is a platform I built with our team called NASA Connects. It stands for Connecting Our NASA Network of Educators for Collaborating Together in STEM. It's quite a mouthful, but in true NASA form, we built an acronym around the premise of what we're trying to achieve. The idea behind this platform is that we are building a professional learning community of educators to connect and collaborate with each other, but also us at NASA. Many of our scientists and subject matter experts are giving ongoing webinars similar to this one, and we're constantly providing updates, curriculum, lesson plans, activities, and so on in this platform. So I encourage you to register for it, give it a try. And I also wanted to highlight another platform I'd love you to sign up for called Earthrise. And this is a monthly curated e-newsletter that I am working with other federal agencies such as NOAA, the NSF, the Department of Education, the USGS, and many others. And we are coming together as a team every month to bring the best of our resources that we think will meet our community members' needs. across a variety of domains, from multimedia to tools to different data sets to different ways to visualize data sets. And so if you click on that QR code, that'll take you to a very easy registration link, just your name and email, and you will be well on your way to joining the Earthrise community. And I also encourage you to explore the NASA Science Activation platform. This is a great way to join extended programs from NASA's Science Mission Directorate. Globe is part of this, amongst many other teams. And if you're interested in learning how to do remote sensing, how do you utilize our data? How do you use our satellites? The RSET program, the Applied Remote Sensing Training Program, is a very powerful training program. The videos, the webinars that are on here, every time I roll it out, everybody says it always works, which is really unique. But RSET is a really critical tool in learning how to do remote sensing, and I encourage you to give it a try. And I see I'm rolling out too much time. Also, one other item you want to look at is My NASA Data. Check out our citizen science programs. And I would also encourage you to take a look at the Earth Day Toolkit, which is just rolled out for our upcoming celebrations for Earth Day. Thank you, Dorian. I see I went a little bit over.
So much. No, appreciate it. And by the way, the Earth Day Toolkit is already in there in your resource packet. I have been, and we can go ahead and let our next speaker, who is she's just going to blow you away. She'll be our final speaker, Liz Saccoccia. She is going to now tell us how so many of these different data sets are used. And somebody had asked this question for real world applications. And most of the links that people have talked about and people have been asking about, how can I get involved? How can I learn more? All of these are in that one URL to rule them all, which I create because it's awfully frustrating to go through and try to keep track of all these different links and then make sense of them. So I have curated and collated an entire resource packet for you and just stuck the link in there again. So I love to see that people are asking these questions. And gosh, I'm so excited. Thank you so much, Liz. And without further ado, the floor is all yours. We're looking good.
Great, thanks, Dorian. And you can hear me okay?
Hear you perfectly, thank you.
Great, perfect. Well, first of all, thanks so much for having me. And to Dalia's point, I am inspired by all of these presentations and all of the data. So I don't forget at the end of my presentation, just a shout out to all of the NASA data scientists and everyone who's making this data available for certain use cases. And that's what I'm going to talk about today. So as Dorian said, my name is Liz Saccoccia. I'm a water security associate at the World Resources Institute. And I'll be talking about really my passion project is the Water Peace and Security Partnership. And we harness the power of data for water security and peace. And I'll try to call out some of the US government data sets, the NASA data sets that we're using. All right. Great. So I'm sure you all have heard all of these quotes that water wars are coming. And, for thousands of years of human history, there have been tensions and there's competition around water resources. We see in the Pacific Institute's water conflict chronology that conflicts over water or where water is used as a weapon of war are increasing. And unfortunately, in the last year, we've seen that happen so much between blowing up the dam in Ukraine and then the destruction of water systems in Palestine as well, and violence about the Helmand River water resources between the Taliban and Iran. So there's no doubt that, poor water resources management can increase tension and lead to violence. But we also believe that water can be a pathway to peace because water is too important that nations can't afford to fight over it. And it actually fuels greater interdependence. So with the uncertainties of climate change and increasing water demand that we're predicting, we're hoping to improve water management to avoid tension and conflict and lead to improvements in human well-being. And I'm going to show you how we use NASA data specifically to do that. So the Water Peace and Security Partnership aims to address water-related conflict by developing innovative data and tools. We raise awareness about water challenges around the world. We build capacity through online videos, and we support dialogue in regions affected by water challenges or water competition. And we do that in order to turn the vicious cycles of water and conflict into virtuous cycles of water-based peace and cooperation. So to give you a graphic of what that looks like, the goal of WPS is to disrupt cycles of water challenges, unsustainable water management, and competition and disagreement and conflict. And we're going to put some effective water management into that challenge, which should lead to cooperation and exchange and sustainability, peace, and development. And that's our goal. So how do we do that? So let's start out with talking about data and tools. So we have an early warning tool, and this will help users understand where, when, and why conflict related to water will happen, and to enable them to create timely and effective water-related interventions to mitigate conflict and promote peace. So we have conflict forecasts to predict conflict, regional causal models to better understand the causes of conflict, and an early warning tool to view this data. And ultimately, this quote by a partner organization said, this analysis can help prepare countries before an armed conflict arises and put in place appropriate and sustainable climate prepared solutions. So I added a note on the different data products on the US government data sources we use. And this is so incomplete, I will just say. We're using a product called ERA3 that uses a ton of NASA products to validate it. We use CDAC data, cropland data from USGS and NASA, and so many more. So I couldn't list them all, but a tool like this would not be possible without incredible global data sources from the US government. All right, so in addition to our Water Peace and Security tool, WRI released the 4th version of the Aqueduct Water Risk Atlas this past summer. And Aqueduct maps and analyzes current and future water risk around the globe. And this is useful in preventing water challenges and competition by enabling users to understand the level of water stress and the causes of that, to establish and agree on a plan for water management today and in the future. And we have a lot of corporate users who use this to understand their supply chains and business impacts on water to prioritize water efficiency measures or water replenishment in water basins where they're using a lot of water to not contribute to more water stress or competition for the people that are living there. And so again, there's so many different data products that this is using, but just a few to validate the model behind and to create the model behind Aqueduct was GRACE, data from the Snow and Ice Data Center, NASA TRIM, which I think was mentioned before, EOS, and many, many more as well. All right, so the last tool that I'll talk about is Global Water Watch. And this tracks the surface area of over 70,000 reservoirs worldwide. And we're hoping to build peace and cooperation on water-related challenges with this tool by establishing a common truth on water resources. So droughts often transcend national borders, right? If there's drier conditions upstream, there's probably dry conditions downstream too. And by making sure that everyone agrees on how much water there is, we hope to avoid distrust between people who are sharing water. We hope to simplify and economize data collection. So instead of having to go out to different reservoirs and actually measure that on the ground, we're hoping to use satellite data to do that faster. Data from satellites has been useful in monitoring water sharing agreements, transboundary agreements all over the world. And we're hoping that Global Water Watch can support that. And also, this is kind of an interesting point. I was talking with a colleague from USGS, and they equipped Iraqi water managers with training in remotely sensed water data, and they were able to better negotiate water resources with upstream countries, Turkey in particular, by showing them that they had information on how much water resources were available and that there really were enough to share a little bit better. So it's an interesting way to democratize access to really important and powerful information. And so far, this is just using Landsat data for the most part, but we're hoping to, oh, I forgot my visual. We're hoping to update this, and I'll skip this and start the visual here, to include things like seasonal forecasts so that people can better understand how much water will be in reservoirs and if there are events like day zeros happening. We're hoping to measure water quality in these reservoirs to make sure that the water that's being used, if we're sourcing drinking water or others, are really clean and useful, and a few other tasks there, like expanding the coverage to include more reservoirs, and also looking at surface area dynamics for rivers and lakes. Okay. So those are the data tools that we have, but what we realize is not everybody is a data dork, or not everyone wants to go through all the data and analyze it themselves. So what we also do is try to build peace through building awareness about water-related challenges and solutions through our quarterly reports. We go into detail about places where there are challenges on water, and share more information on that. So I just want to show a huge shout out to NASA Earth Observatory team, because they'll take the different data sets that NASA's creating, tell stories around it, and then we can use those to add color to the stories that we're talking about. So I always put quite a few of these in our quarterly reports to discuss situations of water and challenges around the world. All right. And then lastly, in addition to the data and the quarterly reports, tools and data are great, but if the information is not being used, if it's not in the right hands, it's unfortunately not making an impact. So what we do is give trainings on how to use the global tools and data. And we work with water managers. This is from a training in Amman, Jordan that we just gave with water managers from 9 different countries on how to use these tools, and then also developing things like community developed causal loop diagrams to promote conflict-sensitive water management in their regions and where they're working and creating water policy. And then also WPS works with creating more dialogue and talking with different groups and working on better water management together in places that are affected by water challenges. So with that, I will end the presentation with just a huge thank you again to all of the people creating this data and for making it freely available, because there's no way that we could do this work and that we could, work on water and security, on peace building without this data being open and free. So thank you again, and thank you for having me.
Boy, Liz, thank you for just finishing things up. I mean, I think it is so cool to see we can collect this data, but at the end of the day, it's just data. But then to see what a nonprofit organization can do by taking these data and making them available to people who have questions but don't really know that there's data out there to answer some of their questions. And if there's not data, maybe kind of coming up with some interesting creative ways to at least nudge and get to the parameters. So like I say, when I learned about what you were doing, and what World Resources Institute was doing, and learned about the Peace and Water Security Initiative, folks, it is so amazing. So I do hope you will make and take some time to dig into that resource packet that I shared. You will find that there's a whole section on NASA's Earth science. And when you dig in there and just scratch and sniff and poke around at some of those things, there are some of those links where you will just simply get lost. I get lost just going in there and imagining